Miss. Good morning, Miss.
Assalamualaikum guys. How are you all?
Walaikum assalam, Miss. Fine.
Miss.
How are you?
Alhamdulillah, I'm fine. So I can see still some of girls are joining. So I will just wait for a few more seconds for them. Then we can start our class. So girls, by the time you tell me, did you go through lesson 5?
Yes, Miss.
Okay. Is there any particular doubt you have?
No.
It's kind of easy, right? This particular lesson. If you
Yeah.
understand the basics, then it is kind of very easy for you to.
Like we have learned this before, so it's kind
Okay,
of
fine. Yeah, that's really good.
Miss, could you explain solidification?
Solidification. Yes, we can go to that point again.
Miss, I have a question.
Great.
Is it a normal change of state from liquid to solid or gas to solid?
Gas to liquid here. Yes, it is. These are all solidification, if you say evaporation, these all are change of state is happening. And as I told you, we are going to have another lesson at the last of this syllabus that is called latent heat. That is actually dealing with the change of states of different state of matter. Okay, so don't worry, we'll be going to that again. But you just remember solidification and condensation is actually nothing but the change of state. And solidification is from liquid to solid, and for that is condensation is from gas to liquid. Okay, that is the point. Nothing else here. It's very similar. It's just a change of state. And in change of state, there is one more point we're going to learn afterwards, that whenever a change of state happens, the temperature will not change. Okay, and why it is not changing, we'll discuss it in our latent heat chapter. But at this moment, we'll be just sticking to the point that whenever there is a change of state is happening, these procedures will be happening. Like, as I said, that is condensation can be there, evaporation is there. So, and we also learned that evaporation and that is boiling, they have two different methods because one needs a particular amount of thermal energy. Another one actually do not need any thermal energy. It takes thermal energy from the surroundings. Isn't it, girls? Okay. Now tell me, do you have any other girls is having any doubt in this particular lesson? Did you go through?
Yes, Miss.
Okay, very good. Now you tell me, is there anyone who already completed learning this lesson?
No.
Okay, fine. I understand because just yesterday you have completed the lesson. So you are going to learn it during this weekend and all. But I hope you have gone through so that we can start solving the past paper question. As I told you yesterday. Shall I do that? What do you say, girls?
Yes, Miss.
Okay, fine. Very good. So let's do one thing. I want you to go to 32 May June, question number, sorry, 32 May June 12, question number 6. All of you go to 32 May June 12. In 31, we don't have any question. So 32 May June 12, question number 6. All of you go to page number 12, question number 6 of that variant, 32 May June 12. Okay. Now, all of you check the question very carefully, then we'll go for the answer. But you have to find the answer yourself, as you already understood the lesson very clearly. So, I want you to do it like this. So, all of you check the question.
Is it question number 6?
Yes, dear. Question number 6. Did you notice there are two t-shirts are there and there's a pants, isn't it? I hope you got the question.
Yes, Miss.
Okay, fine. So just check. First, I want to give you time to check the question, read it, and then you'll suggest me the answer. Okay. Now, all of you check the question. Now, tell me, guys. I hope all of you have the past paper in front of you, and take a pencil as well. Because when we're discussing, if you need to write any point, we'll be writing. Later, you complete the answer. But first, make sure you got the question. Okay? Now, I want all of you to
Miss,
take this.
can you repeat the variant?
That is 32 May June 12, question number 6, page number 12 on that particular question paper. Page number 12. Okay, guys. Now, let's check this question. They said that two students hang out identical t-shirts to dry at the same time in the same neighborhood. The only difference between the drying condition is that t-shirt is sheltered from the wind, from any wind. Okay, one t-shirt is sheltered from any wind and the other is in a strong breeze. The figure shows that, means one is beside the fence, another one is open. Okay, state and explain in terms of water molecules the difference between the drying times of the t-shirt. So girls, by looking at the diagram and the discussions that we had yesterday, could you suggest me that which t-shirt is going to dry faster and which one will take more time to dry up?
Miss, could you repeat the variants?
32 May June 12, question number 6. And I know that most of you, the books you are carrying, there you have 31 and 32, both the variants, isn't it? So it is there in your book. Check.
Miss May June.
May June, yeah? Yes, that's what I said, May June. 32 May June 12. And question number 6.
Miss, I joined in late. Could you repeat?
32 May June 12, question number 6.
Miss, which past paper?
Paper 4. 32 May June 12, question number 6. Got it?
Miss, is it the strong breeze?
Yeah, like the strong breeze.
T-shirts.
Because
Yeah.
of like increase in temperature, water molecules escape faster.
Okay.
Faster from the surface.
But there's 2 marks, so we need to explain a little bit more. So I want you to tell me again. Okay, just 1 minute, one person will discuss. Because if all of you say, we cannot get this one together. Okay, so I want, who's there? Ragad, could you suggest me what would be the answer for that one?
Okay, the strong breeze will dry faster because there's more space, like it's not closed, so that the water molecules can escape faster. And
Okay. But do you remember yesterday we discussed at one point that when we have a breeze, means they say there is a strong breeze. So when there is a breeze, what will happen to the evaporated molecule from the t-shirt?
it will be faster, right?
It will be faster, but at the same time,
They will
be
gain
carried
energy?
away. No, they will be carried away by the wind itself, isn't it? So we have
Yes,
to
yes.
mention it that evaporated water molecules are quickly removed by the wind because we have a strong breeze there.
Yes.
Okay, and one more thing is there. If the breeze isn't there, means the wind isn't there, there's a chance that some of the water molecules might come back to the t-shirt one more time. So there is a less chance of the water molecules coming back to the t-shirt. We have to mention that as well. Okay, guys. So do you agree with her answer? Ragad, the answer Ragad gave, girls, do you agree with that? Is it
This.
correct? Okay, fine. So let's do it. I will read out. I want you to check and write it yourself. Okay, guys? Because she gave us all the point, but we need to just rearrange the answer. Okay, nothing else. Her answer is correct, but we have to just arrange it in a proper way. So I'm reading out. All of you just check. T-shirt on strong bridge dries quicker. Okay, and because the evaporated water molecules are quickly removed by the wind. You can put a full stop there. There is less chance of the water molecules coming back to the t-shirt. This point you have to mention because when the air molecule is taking the evaporated water molecules away, that will actually increase the evaporation procedure or the drying procedure faster. If they are staying closer, if these evaporated water molecules are staying closer to the t-shirt, there is every chance that they can come back to the t-shirt one more time. So we have to block that one as well. Okay, and that is done by the wind actually. So is it clear, Amira? Are you following me? Is it clear to you now?
Miss, could you repeat one more time?
Yes, sure. So all of you listen to me. T-shirt on strong bridge dries quicker because the evaporated water molecules are quickly removed by the wind. Because the evaporated water molecules are quickly removed by the wind. And there is less chance of the water molecules coming back to the t-shirt. Less chance of water molecules coming back to the t-shirt.
Miss, could you repeat from because?
Okay. Because the evaporated water molecules are quickly removed. Because the evaporated water molecules are quickly removed by the wind. And there is less chance of the water molecules coming back to the t-shirt. And there is less chance of the water molecules coming back to the t-shirt. Okay, fine. Maria, are you there?
Yes, Miss.
Okay. Did you write the answer that I told you? Because you joined late, Maria. Did you find out the variant? The one I'm... Okay, very good. Is it done? Shall I move to the next question?
No, miss, there's less chance.
Okay. There is less chance of the... 1 minute, let me finish. There is less chance of the water molecules coming back to the t-shirt. Got it? Okay. So now shall I go to part B of the question?
Yes, Miss.
Okay. Now check part B. They said they gave us another diagram, another figure where we can see the two t-shirts are there, but one is folded double and another was hanging just the way it is. So they are asking us, state and explain in terms of water molecules the difference between the drying times of the t-shirt. Okay, I want Mahmuda to give me this answer. Mahmuda, are you there? Could you give me the answer of this one?
Miss, I don't have this paper.
You had it before, isn't it? What happened, Mahmuda? What is it?
Miss, can you repeat the variant?
32 May June 12. Question number 6 here, dear. Mahmuda, did you lost your past paper?
No, Miss, I can't find Major 12, 3, 2. The rest of the variants are there.
Okay, fine. Later you download it again because you need these questions to be solved. Because these are the range we gave, accordingly we did. Okay, fine. What to do now? Now you check the rest of you. Okay, I want whom to give me the answer. Okay, Mamita, are you there?
Yes, miss.
Okay, dear. I want you to give me the answer of this question, part B. Did you check the diagram or the figure that is given there? There are the two t-shirts. One is hanging just the way it is. Another one is folded double folded. And they're asking which one is going to give us this drying time, less or more. Means we have to give an idea about the drying time. Okay. So, Mamita, could you give me the idea of this answer? What do you think? Which one is going to dry faster and why will it dry faster?
Miss, can I?
Yes, Mamita.
Miss, can I give 1 point? But
Yes.
because of
Okay, fine. Mamita is still thinking. Okay, fine. Sadia, you give me your idea. No problem. Let's continue.
the shirt is not folded will dry faster due to the surface area because the water molecules will have a greater chance to escape from the liquid surface.
Yes, you're right. Absolutely correct answer. But we'll be writing in a bit or organized way. Your answer is correct. Your conception is also correct. So let us continue. All of you check this answer. T-shirt folded double dries slower. T-shirt folded double dries slower because folding decreases the surface area. Okay.
Can you repeat?
Yes. T-shirt folded double dries slower because T-shirt folded double dries slower because Because folding decreases the surface area. Folding decreases the surface area of the t-shirt exposed to the air. This point is important. Folding decreases the surface area of the t-shirt exposed to the air. Exposed to the air, comma. So, less water molecules will evaporate. So, less water molecules will evaporate. Full stop. Okay. I will repeat the whole answer one more time. All of you check. T-shirt folded double dries slower because folding decreases the surface area of the t-shirt exposed to the air. So, less water molecules will evaporate. Will evaporate. Full stop. Okay. Girls, yesterday, do you remember I told you that evaporation is a surface effect? Do you remember that, girls?
Yes, Miss.
Yes. So, yes. Now, that point came over here because as it is a surface effect, the more the surface exposed to the air, the more faster is the evaporation process. So, we picked that point in this particular part of the question. Is it clear, girls?
Yes,
Are you done with the answer? Shall I proceed to part C?
yes, Miss.
Okay, fine. Now, this question is for Amira. You'll read out and you'll try to suggest me the answer. Check. A runner in a hot country feels cooler if she pours water over her hair to keep it wet, even when the water is at the same temperature as the air around her. Explain in terms of change of state of water why she feels cooler. If you remember, yesterday in the class, I discussed this point, isn't it? Amira, do you remember that? Yes. So could you rearrange this answer and tell me how we do put it in that particular question? Yes, Amira, I'm waiting. Yeah. Yes. Do you have it with you?
I do have the first picture.
What? Till now, what you were doing then? You have it?
Writing the first.
Okay.
Miss,
Yes, Mahmouda said.
can I answer?
Could you tell again? I didn't hear you clearly.
Can I answer?
Sure, sure.
Water evaporates from her hair.
Hmm.
While evaporation, the water molecules takes heat from her hair, and so from her body, the body loses heat, so the body feels cooler.
Yes. Yeah, you're right. That is the explanation we had it as well. Very good, Mahmouda. Yes, that is how we are going to write it. It's actually nothing but the evaporation process is happening. And they say here the change of state of water. Definitely, water is becoming gas molecule now. Okay, all of you. Check it. She feels cooler because water evaporates from her hair. To evaporate water, the required heat flows from the body and hair and leaves the runner's body cool. That's right.
Feels cooler
Because water evaporates from her hair. Because water evaporates from her hair. Water evaporates from her hair. Okay. To evaporate water, the required heat flows from the body and hair, flows from the to evaporate water, the required heat flows from the body and hair.
flows.
Yes, flows from the body and hair and leaves the runner's body cool. And leaves the runner's body cool.
Miss, what's after and?
And leaves the runner's body cool. Okay. Now, girls, if I ask you, can you give me the whole answer in a single sentence? Who can give me the answer? Just a single sentence. I don't want any more explanation over here.
Miss, can I repeat it from the first?
Okay. By the time the rest of you girls think about how will you give the answer in a single sentence. Okay. I'm reading the answer one more time, Maria. She feels cooler because water evaporates from her hair. To evaporate water, the required heat flows from the body and hair and leaves the runner's body cool. And leaves the runner's body cool. Done, girls?
Yes, Miss.
Very good. Okay. Now, I hope someone from your group might have got the answer. How would you write, or what would you write if I want you to write down the answer for a single sentence? Just a single sentence.
Water evaporates from her hair.
Okay. Anyone else? Because I'm
Miss,
not.
it can be the thermal energy or heat energy in the body flows, and then the water makes her feel colder.
Oh no, dear.
Miss, there's a cooling effect.
Okay, Maha, could you repeat the answer, the one you were trying to say
Miss,
now?
there is a cooling effect.
Yes, this is the answer I was looking for. You have to just write down evaporation has a cooling effect. Done. Okay, Safa wrote something here. Faster molecules escape, leaving water cooler. But the main point will be evaporation has a cooling effect. Done. That's the single line answer. It could be. Because that is the statement leads to us all this explanation. Isn't it? Thank you, Maha. Okay. Now I want you to go to 31 October, November 12. 31 October, November 12. All of you proceed to that variant. Yes, I'm telling you, hold on there. 31, let me even turn out the pages. Yes, 1 minute. 31 October, November 12. Question number, we are going to do 1 minute, 7. All of you go to 31 October, November 12. Question number 7. I'm waiting. All of you search the question. That is page number 10 of that variant. Question number 7. Okay. All of you check. 31 October, November 12. Question number 7. Did you find? There are 5 containers with some water inside.
Yes.
Got it? Okay, very good. Now, Mahmuda, do you have this variant with you now? Mahmuda?
Let's repeat the variant.
31 October, November 12.
And
31, question number 7.
Miss, will do the whole?
Inshallah. Because this whole question is from our portion. So we can do this. Okay, Mahmuda, do you have this variant with you now?
Yes, Miss.
Very good. So let's do it all together. All of you read the question. The first one you'll be suggesting. Every question you'll be suggesting an answer. If I need to mold the answer, I will tell you. Otherwise, you can continue with the same. No worries. Okay. Number 7A. Explain why a liquid cools when evaporation takes place from its surface. Okay.
Evaporation has a cooling
Is a
effect.
cooling effect?
Yes, this is the statement, but we have to explain here because 2 mark is given. Explain this. Explain. Okay. Now, do you remember the procedure of evaporation? What happens? The procedure.
Miss, is it?
Yes. Yes, Tanzila, you want to say something?
Miss,
Say.
I wrote the answer.
Say, please.
If the faster moving molecules escape from the liquid surface, the kinetic energy of the remaining molecules, so the temperature of liquid is less than before.
Yeah, you're very close. It's correct. Faster moving means they are going to have more energetic molecules. We call them energetic molecules. Okay, fine, no problem. You can continue with that. But I will be reading out the answer for the rest of the students. You just check. But the idea Tanzila shared with us, that's absolutely correct. Because this is the only idea we have. Yes, fine. Very good. No problem, Safa. You can continue. Just listen to my answer. You don't need to make change. Just listen to it. The more energetic molecules, that's what we say, the more energetic molecules escape from the surface, isn't it? Because it is a surface effect, right? So the more energetic molecules escape from the surface, leaving behind the molecules with lower energy. So
The
that
more energetic
molecules escape from the surface, leaving behind the molecules with lower energy. Leaving behind the molecules with lower energy. Leaving behind the molecules with lower energy. So the temperature of the liquid goes down. So the temperature of the liquid goes down. Yes, Safa is correct, no problem. You can continue.
lower energy.
Lower energy, so the temperature of the liquid goes down. Because 2 marks, so you have to explain a little bit. Then Amira, shall I proceed?
Yes.
Okay, even though I will just read out one more time, the rest of you check it carefully, okay? The more energetic molecules escape from the surface, leaving behind the molecules with lower energy. So the temperature of the liquid goes down. That's it. Okay? Fine, guys. Now, all of you look at the part B of this question. Okay? If you just look at it, you'll find that they say figure 7.1 shows 5 vessels, each made up of the same metal and containing water. But if we just look at them, their size and the shape is different. A, B, C, D, E, they have different shapes, different size, and they gave us a table. The table shows detail about. Guys, could you hear me?
Yes.
Yes, fine. Let me continue. Okay. The table shows details about each vessel and their contents. Okay, each vessel and their contents. Okay, fine. What they are doing it over here. Then vessel A, they gave the outer surface. Did you notice here dull, shiny, dull, the information they gave us? Right, guys? I hope you are checking it carefully. Okay, fine. Yes, now, okay. After that, if you just look at it, volume of water, the 3 container is having the same amount of water, then less, again same. Then initial temperature of water also they have given to us. The following questions are about the time taken for the temperature of the water in the vessel to fall to 10 degrees Celsius from the initial temperature. So whatever temperature these waters were having initially, it has to fall by 10 degrees Celsius of the initial temperature. So they are asking us some questions regarding it. Explain why the water in B takes longer to cool than the water in A. So it is a relationship between or a comparison between A and it's A and B. Okay. So Mahmuda, I want you to give me the answer. Just check the information given for A and B and then tell me what could be the answer of this question. Okay. Just check it.
Okay.
Read out or check what are the information given for vessel A and then vessel B and what is the difference. 1 minute.
B
I asked Mahmuda. Yes, Mahmuda.
B is a shiny surface and A is a dull surface.
Okay.
B radiates slower because B is a dull surface. So it takes longer time to cool.
1 minute here. B is a shiny surface. It's not dull. Check it carefully again. Look, they say here, explain why B takes longer to cool than water in A. So,
Can I finish?
say which one will take longer time. First, you decide that.
B.
Vessel B. No,
Yes.
no, no. Oh, sorry. Yeah, they already mentioned it. But explain why the water in B takes longer to cool than water A.
Because shiny surface is a poor radiator.
1 minute. Yes, that I'm coming to that one. Listen. Here we have to say something about the vessel A, actually. So you can write what is there in vessel A. It is dull. Okay, fine. So
Surface is a better radiator.
yes, fine. That's a good answer. We can write it like this.
Miss,
Because
it,
it's
Miss,
one
it
mark
reflects
only.
most of the terminology.
Okay. Maria, I think it is better. Let us write down about A. Because B already they mentioned it takes longer time. But why it is taking longer time? We have to say that vessel A is taking less time. That's why it is taking long. Okay, 1 minute. I can see Safa wrote an answer. Shiny surface and A shiny surface. Yeah, both the way it is correct. So since it is only 1 mark, so we can just write down vessel A has dull surface and dull surface is a better radiator. If you write on the other way that vessel A, B is a shiny surface and shiny surface is a poor emitter. That can also be has dull surface and dull surface is a better radiator, emitter, both the way you can write, no problem. It is like the glass is half filled and the glass is half empty. You can write with A, vessel A or vessel B. Both the way it will be correct. Because that is the comparison between these two. Isn't it?
Miss Vessel A has dull surface then?
And dull surface is a better emitter. And dull surface is a better emitter.
Miss, can you repeat it?
Yes. Vessel A has dull surface and dull surface is a better radiator. You can write on the other way as I say. Vessel B is a has shiny surface and shiny surface is a poor emitter. But that also you can write. Okay. I think we are done with this particular question. Let's go for part 2. Explain why the water in C cools more quickly than the water in A. So you just have a comparison between C and A.
The water in C has higher temperatures than the water in A.
Yes, but you forgot one word there. Initial temperature. Higher initial temperature. That point we need to discuss. You said the correct answer, but you forgot a single word. You have to mention initial temperature because look, C has an initial temperature of 95 and A has an initial temperature of 80 degrees Celsius. Okay, so definitely it will be C because it has more temperature. So you can just write down
So the correct answer is the water in vessel C has a
more
higher initial temperature
fine.
than
A, that's it. Then A, that's it. Correct. You can write in this way also. Initial temperature of water in C is more than in vessel A or in A. Is more than in A. Clear? Is it done, girls? Shall I move?
Miss, could you please repeat?
Okay. As I say, that initial temperature of water in C is more than in A. You have to just compare them. All the other things were similar. Only the temperature was more in C. Initial temperature, definitely. Okay. Now let's go to 3. Explain B, that is B3. Explain why the water in D cools more quickly than the water in A. So you check D and A.
Can I try answering this?
Yeah, sure. You can, no problem. Yes.
Because the volume of water in D is less than the volume of water in A, basically.
Okay, let me see. D has 100 and yes, that can be the correct answer. Yes, very good, Sadia. If you compare, they have only difference. One is having 100 centimeter cube of water, another one 200. So definitely the volume of water at D is less than the volume of water at A. Correct?
The
water in D is, okay, no, you have to mention the volume. The volume of water in D is less than the water in A. Less than the water in A. That's it. Okay?
sorry.
It's okay there. Now let's proceed to number 4 of this question. 7B4.
Miss, can you
Miss, sorry I
repeat again?
lagged. Could you repeat?
Okay,
Sorry,
okay.
I made the noise. My mom called me.
Okay, fine. I'm reading now. Explain why the water in D cools more quickly than the water in A. Okay, so the volume of water.
Because it has a high, because there is more surface area exposed to the air.
Amira, let her repeat it.
1 minute dear.
Is she repeating the
I'm,
answer?
yes,
I'm
I'm,
sorry.
yeah. 1 minute,
It's
just hold
repeating
on.
the last question's
Yes,
answer.
yes, it's okay. Let me repeat. The volume of water in D is less than the water in A. That's it. Okay. So I hope 7B3 is done. Shall I proceed to 7B4? Okay. Let's check what is written there. Suggest 2 reasons why the water in E cools more quickly than the water in A. Okay. Now I can see, I think Safa wrote this answer, the first point as the surface area. Yeah, that can be the correct answer for 1 point, because if you just look at it, it has more surface area. So you can just write down water in E has more surface area than water in A.
And Miss, is there another reason for being shallower?
Yeah, that can be shallower. Okay, it can be done, but first you write about the surface area. That's important to us. Water in E has more surface area than water in A. Okay. Next one is that why the water, okay. Do you remember one thing we learned, that is about flow of air that increases the evaporation procedure? Yesterday we discussed about it, right?
Yeah,
So let's write down that point also. Flow of air in E.
Can you repeat the second one?
Yeah, flow of air in E, because we're not sure about that, they didn't say, so we'll be saying may increase. Flow of air in E may increase loss of heat by evaporation. Yeah, I can say that Sap already wrote that one. So no problem.
Can you?
Yeah, flow of air in E may increase loss of heat
Flow of
by blow of air. Air, E.
May increase loss of.
What's E?
E means the container E there. Look at the diagram. We are referring
Oh,
to E.
okay. E.
Yeah.
I heard he.
No, dear. It's E. Okay. E may increase the loss of heat by evaporation. May increase loss of heat by evaporation. Okay?
Means you have a less than a minute.
Yes, no problem. We'll join again. Okay. After that, I want you to go to 32 October, November 12, question number 5. That day we did 4, I remember. Now let's go to question number 5. Okay? That is 32 October, November 12. Question
Miss,
number.
we did 4B. We did 4B, not 4A.
Uh, welcome back, girls. Yes, dear. All of you join quickly. And who was telling me that we didn't do that question? I did it. 4A and 4B. The whole question I did with you in my previous class last week. I remember. Who was that saying that I didn't do 4A? No, dear, I did. 4A and B, both. Okay. So today I want to do question number 5. Question number 5. I want you to go to 32 October November 12. Question number 5. Okay? Did you find the question?
Yeah.
Okay, very good.
Miss, can you repeat it there again?
32 October November 12. Question number 5. There was 2 coffee cup. That question I want you to know. 2 coffee cup question check.
Copy.
Did you find?
Yes, ma'am.
Very good. So let's do this. Now I want you to read it, then we'll proceed. Okay. They said, look,
We
figure.
do this often in our daily life.
Which one here? I'm doing it now. 32 October.
This question.
Okay. Before that, someone tell me who said that I didn't do number 4A.
Me.
Who's that? Saida. Are you there? You said, right, that I didn't do?
No, miss.
Then who's that? Amira. But I think, okay, the rest of the girls tell me, didn't I complete question number 4 full? A, B, all?
Yes,
Yes,
yes.
miss.
Yes, I did it, I remember, because it belongs to the portion that we finished already. Okay, guys. Now, do one thing. Let's go to question number 5. Okay. Now, let's take, what did they say? Figure 5.1 shows a thin plastic cup containing hot coffee. Okay. Then hot coffee. And then what happened? Which an IGCSE physics student gets from a machine. Fine. Figure 5.2 shows how another student who finds an empty second cup has placed his identical cup of coffee inside this second cup. Okay, if you just look at the diagram, you can see clearly. One is having a single cup, another one they put it inside another cup, inside another cup. They called it double cup. Okay, so suggest and explain a difference that the students will feel when holding the cup. Okay, now this answer I want Mahfuza to try. Mahfuza, are you there? Could you try this answer? This part of the question?
Yes, miss.
Yes, dear. Could you check and tell me which one you think how the students will feel? Think about you are holding the single cup and Mamita is holding the double cup. So, what could be the difference between your feeling?
Miss, the student with the double cup will feel less heat from the cup.
Okay, sure. But why it is like that? You have to explain.
Miss, can I?
1 minute. Let Mahfuza finish. Then Sadia, you try. Yes,
Miss,
Mahfuza.
because of the material of the cup.
Is it material of the cup you said?
Yes, miss.
No, dear. It's not about the material. It's something else. Could you just look at the diagram and
Is
think
it
twice?
because the
The space
Yes.
between each of the cups.
heat is trapped in between the cups?
It is, Mamita, okay, 1 minute, Mamita. Could you repeat? I couldn't hear you properly.
The heat
The
between
heat
the
is
space of
trapped
the
between
cup.
the cups.
I'm not sure. Yeah. First of all, you tell me one thing. As I think, who's there? Yes. Just 1 minute. Let me see. Someone gave me a message here. Safa for this. Okay, fine. There is a space between the two cups. I know that. And I want, Mahmuda, you were saying something. Now you tell me, what do we have in between the two cups? That space that we have there. What do we have there?
Vacuum.
No. How could it be vacuum?
Air.
Air is there.
Air.
Very good. Who said that? Air?
Yeah. Amira.
Okay, fine. Good answer here. Because when we tap, okay, now let me define this whole thing clearly. When we place a cup on the top of other cup, definitely in that empty cup there was air and we placed it, so we trapped some air in between. And air is a bad conductor. Okay, air is a bad conductor and is a good insulator, in fact. Who's that? Safa wrote bad insulator. No, dear, it's a good insulator. It's a bad conductor, good insulator. So bad conductor, that is why the student, now I'm telling Mahfuza that the student who was holding the two cups will feel less heat in the hand because air will not allow the heat to come to the other cup and she will feel comfortable. Is it clear what is the mechanism going on in between? Mahmuda, is it clear for you? Yes, dear. Say, who's
Yes,
that?
miss.
Yeah, say.
It may be out of the syllabus, but
Who said
you
it?
know when we drink
Okay, okay. Amira, yes, say.
Miss, when we drink something hot to make it colder, we pass it from one glass to another. How
Yes.
does it become colder?
Okay. When you're passing from one to another, it is getting more exposed to the air. That is why it is releasing more thermal energy to the surroundings and it gets cool.
Okay.
Physics always there. Okay. Let's do it. I'll just read out. I want you to, but first you tell me, is it clear for you, the conception? And one more thing to Mahmuda. Mahmuda, you say that there is vacuum. Vacuum is only possible when you are using a vacuum pump to take the air out. But we didn't do anything there. Right, guys? We just placed one on the top of other. So we trapped some air in between the two cups. That helped us to use this procedure to keep our hand cool. Okay, even if you see in Riyadh also, if you just go out, sometimes you'll see the people who are drinking coffee or tea on the road, you'll sometimes see they're holding two paper cups together. They don't know physics, I think, but they're taking the advantage of physics without knowing it. But right now we learned it, right? What is the purpose behind it? Isn't it interesting, girls?
Yes.
Very good.
Yes,
So
Miss.
let me read out the answer for you. We'll be writing it like this. The student will not feel so hot to hold the double cup. That is the conclusion, first of all. The student will not feel so hot to hold the double cup. The student will not feel so hot to hold the double cup. Then you can put a comma. As there is an air gap. Shall I repeat this? The student, yes, the student will not feel so hot to hold the double cup, as there is air gap, between the cups. As there is air gap between the cups, and air is a good insulator. And air is a good insulator. Good. And air is a good insulator. So, less heat will transfer from coffee to the cup and to the hand. So, less heat will transfer from the coffee to the cup and to the hand.
It will transfer.
Will transfer from the coffee to the cup and to the hand. And to the hand. I'll repeat the whole answer one more time. The student will not feel so hot to hold the double cup, as there is air gap between the cups, and air is a good insulator. So less heat will transfer from coffee to the cup and to the hand. Then, okay. Now, part B of the question I want to do a little bit later, because this is a question from the last lesson. So let us only, that's what I'm saying. This part B of the question I'll do a little later. So let's go to part.
I can't hear you.
Why here? Okay, I'll say that.
Miss, your voice became.
Could you take your microphone or something there? Okay. Now part C of the question I want to do. B I will do later with you, because for this theory we are not done till now. So go to C. In C they say, explain why a cup of coffee cools more quickly when a lid is placed more slowly. Sorry, I said quickly. Explain why a cup of coffee cools more slowly. Okay, when a lid is placed over the cup.
Is it because the heat
Exposure
is
to
trapped
the
inside the cup?
Because the particles there are like
Because
they
the heat
cannot.
is
exposed to the
trapped in
wind
the
is
cup.
less.
Because the heat is trapped in the
Air
cup.
exposed to the air is less.
Yes, you can say that. And something more because 2 marks.
Wait, what?
They say here, why
Heat
the
is
cup?
trapped inside the cup.
Yes, you are close. Actually, here, which two process is getting stopped by the lead? You tell me that. Which two process?
Evaporation and
and
cooling.
convection.
Yes, both are right. It will be convection at the same time evaporation. So they are
High
going.
five.
Yes. Okay,
Whoever
fine. Let's
said the other
continue.
answer.
So listen.
High five, Amira.
High
No
five,
more
Saida.
girls. Let's concentrate on our answer. Now listen. They say here we have
Miss,
to.
it sounds like you're speaking from far away. I can't hear you.
What happened suddenly? Before wasn't it very clear to you?
Yes, now
So then what happened suddenly? Okay, let me
Guys,
just say.
just turn the volume of your computer up. It works.
high. It's a
Uh-huh.
high volume.
I think
I'm
I
on my
am.
phone.
But I think it is in the high volume there. Okay, let me check it again. Yeah, it is in 100% here. Okay, fine, no problem. I'll speak a bit loudly. I think it will be clear.
Okay.
Okay. Now let's go for that one. That is, I was telling you yeah, you said that two process is going to be actually stopped by placing the lead on the top of it. So I need to discuss about it. Is it yes? Saida's mic is kind of noisy. That's why I mute her. When you need to ask me a question, unmute yourself. Okay, guys. Now listen. So they said. Okay, now, so we'll be writing first of all what the lead is doing. We'll write the lead reduces heat loss by convection and evaporation. Okay, so
Sorry.
all of you, yes, I'll be repeating. The lead reduces heat loss by convection and evaporation, both. What we
The
mentioned.
lead what?
The lead reduces heat loss by convection and evaporation. Okay? Okay. Now, we have to explain a little bit more. So we'll write down. In convection, heat is transferred from hot to cold region in gas. In convection, heat is transferred from hot to cold region in gas. Now, why this gas point I brought here, girls? Because you know that from the hot coffee, the heat will be transferring to the surroundings, which is air. So definitely gas comes over here. Clear? Why did I write that point?
In convection, heat is transferred
from hot region to cold region in gas. Heat is transferred from hot region to cold region in gas. Now, let us say something about the evaporation as well, because both this process are going to be stopped by the lead. So we write down in evaporation, more energetic molecules escape from the surface. More energetic molecules escape from the surface, thus reduce the temperature of the liquid.
From the surface.
Thus,
could you repeat from the starting?
in evaporation, more energetic molecules escape from the liquid surface, or from the surface you can write. More energetic molecules escape from the surface, thus reduces the temperature of the liquid. Okay? And the part B of this question, you will be doing it, as I said, after completing the syllabus, because the last chapter means the last lesson, we have the topic regarding this particular equation or particular question. Okay, so I'm going to do it with you in the end of the syllabus. Okay. Now, I want to ask you one more thing, guys. Actually, we have more questions from me because we are still in 2012. Okay. Okay, I want to give you a homework first. Could you write down the question that I want to give you to solve? Because next few days I don't have any physics class with you. Next week I'm going to have. So I want you to solve some of the questions from here as much as you can. So could you write down the variance on a white paper and later you find the question and try to solve by yourself? Shall I start saying?
Yes,
fine.
Miss.
Very good. So write down.
Not sure what, Miss.
Yeah. 31 May June 13. Could you tell me loudly, girls? Clear? Yeah. 31 May June 13. Only 5A you do. The rest of the questions you can't do right now. So 5A. Decided it. Write down 5A you'll be doing. 31 May June 13. 31 May June 13. Question number 5A. Now, 32 May June 13. 32 May June 13. Question number 3.
13.
Yes. Question number 3. Okay. Now, 31 May June 14. In between, actually, you don't have any question regarding this topic. That's why I'm not going for that. The one I'm mentioning, you have to do this. 31 May June 14, 7A. That is the question it will be, not the rest. 7A. Got it? Okay, one, yeah, say.
Yes, Miss.
Yes. 32 May June 14, question number 5. 32 May June 14, question number 5. Okay, and the rest I will do with you, inshallah, next week. But guys, let me tell you one more thing. This week, Thursday, I might give you 3 pages of the next lesson to write down during the weekend. So that next week, yes, dear, 3 pages only I'll give you. What happened, Amira? Why are you becoming so lazy again? No.
No, I still finish writing all the other things.
No, yeah, I will be giving you 3 to 4 pages. You have to write it down in your notebook so that next week when I'll start that lesson number 6, the last lesson of our syllabus, I can quickly explain to you. Okay, girls? As the time is over, today I want to complete my class. I want all of you to have a good time at home, studying, having food, sleeping, taking enough rest. Right, girls? That's the only thing I can. And pray as well. And pray on time. Yes. You can recite Quran, pray 5 times in a day, as well as any nafal ibadat you can do. Right, girls? Okay. See you inshallah next week. Pray for you, pray for me as well, so that all of us should be in good health. Inshallah, we'll meet again. Assalamu alaikum. Bye. Allah Hafiz.
Walaikum assalam. Allah Hafiz.
Allah Hafiz.